All right, now we're going to factor the sum and difference of two cubes. You've done a difference of two squares in the past, so here are some new rules. If I have the sum of two perfect cubes, like a cubed plus b to the third, that's going to factor into a plus b times a squared minus ab plus b squared. Now the ab, of course, means a times b. Notice this is the sum of two cubes, which is a little different than the difference of two squares before, but we have another rule here. We have a cubed minus b cubed. And that will factor into a minus b times a squared plus a times b plus b squared. Now, just take a look at the minuses and the pluses for these two pieces here. It can get a little confusing, but we're going to go slow. Our first example is going to be x to the third power plus 27. Now, I'm going to rewrite this so we can clearly see what a and b are from the rule above, and I'm going to write in parentheses an x. That's raised to the third power, plus, parentheses, 3 raised to the third power. Now I can clearly see that using the rule above, I have that a is x and b is 3 in this case. So this is going to equal, I'm just going to use the rule above, a plus b, which in this case is x plus 3, times, now a squared, a in this case is x, so I'm going to get x squared. Minus. Be careful of that minus there. It's easy to miss that. Now, a times b in this case is going to be x times 3, which is just 3x. Plus b squared. Again, b is 3 in this case, so b squared, or 3 squared, is just 9. And just like that, I've completely factored it. The right-hand set of factoring does not factor. So this is as far as we can go. Let's try another example. Z to the third minus 8. Again, I'm going to rewrite this as z raised to the third power minus 2 raised to the third power. This way I can clearly see, if you look above to the rule, that a is z, b is 2 in this case. So very nicely this is going to quickly factor into z minus 2 times a squared, which is z in this case, so z squared. It's going to be plus now. I can be very careful with these signs. It's very easy to miss that. A times b is going to be the z times the 2, which is just 2z, plus b squared, which is 2 in this case squared, so 2 squared is just 4. See how easy this rule is? You just have to be really careful when you match up the a's and b's to the proper rule. Next example, we'll start with 27y to the third plus 1. Now again, I'm going to rewrite this as, this is in parentheses, 3y raised to the third power plus, in parentheses, 1 raised to the third power. A in this case is the 3 times y, b in this case is the 1. So looking above the rule, I'm going to get, in parentheses, 3y squared, 3y plus 1. Now we're going to have, in parentheses, 3y squared minus 3y times 1 is just 3y, that's a times b, plus 1 squared. Now I know this looks a little messy, so we'll clean it up a little. I'm going to have 3y plus 1 times 9y squared. Be careful that you square that 3. 9y squared minus 3y plus 1. And that's it. That's the answer. That's factored form. A few more examples. Let's try this next one. We're going to do 125 a to the third power minus 1. Now, again, I'm going to rewrite this as 5a to the third power. You don't have to do this if you see it right away, but sometimes it's easier to see. Minus 1 raised to the third power. So a in this case is my 5a. I know that sounds weird. B in this case is 1. Matching it up to the rule above, I'm going to get in parentheses 5a minus 1. In the parentheses, I'm going to have the 5a squared plus, in this case, again, match it up with the rule above, I'm going to have 5a times 1 plus 1 to the second power. Cleaning all this up, I have 5a minus 1 times 25a squared. Don't forget to square the 5. It's easy to miss that. Be extra careful. Plus 5a plus 1. And that's it. That's the factored form. We'll do 2 more examples. We're going to start with 32x to the third power minus 500 y to the third power. These are huge numbers. That's okay. Now, before I get going on this, I'm going to think back to my other factoring rules, and I'm going to notice that there's a greatest common factor. The greatest common factor in this case is actually 4. So when I factor out the greatest common factor, I'm going to have a 4 on the outside, and inside I'm left with 8x to the third minus 125y to the third. Now, if you just look in the parentheses, I can match it up to a rule above. I'm going to have 4 times, got to keep that 4. That's going to be 2x squared, to the third, pardon me, minus, parentheses, 5y raised to the third power as well. So you'll note, inside the bigger parentheses, I now have a difference of 2 cubes, matching it up to the rule above. This is going to factor into 4, parenthesis, 2x minus 5y. Alright, now this next part, it says take the a, or the first part, the 2x in this case, and that's going to be raised to the second power. Plus, match it up to the rule, I'm going to have 2x times 5y, that's the a times b, plus 5y to the second power. And then we've got to close the parenthesis. Now matching all that up, we're going to end up with 4, parenthesis, 2x minus 5y. Now we're going to have 4x squared, don't forget to square the 2, plus, now multiplying this out, I end up with 10xy plus 25, don't forget to square the 5, y squared. And that actually is my final answer. One more example. We're going to have 54x to the third minus 128 y to the third. Now again, there's a greatest common factor. In this case, it's just 2. So I end up with 2, parenthesis, 27x to the third minus 64 y to the third. And I'm actually just going to skip to the answer, and I want you to see if you can piece it together. Eventually, it's best if you can just jump to the answer. So it's going to be 2 on the outside, of course, parenthesis, 3x minus 4y times 9x squared plus 12xy plus 16y squared. So you'll have to piece all that together just using the rule with in this case, the difference of two cubes. So take a few minutes and try to match that up.